Good afternoon, ladies and gentlemen. You are tuning in to the fifth edition of Engineer Power Talk, brought to you by Engineer 2021. I'm Lillian, and I'm your host for this session. I know it's been a busy week since the announcement of Phase 2 from our government, and at this hour, I'd like to congratulate you for being here. And we believe that there's no better time than now to share about electrical safety and irradiation technology for an improved built environment. Speaking of a busy week, I'd like to ask all of you a quick question. It's gonna be a quick yes or no question. So if your answer is yes, type Y in the comments, and if your answer is no, type N. All right. How many of you present here today is joining Engineer Power Talk for the first time? So type Y for yes, you're joining us for the first time, or type N for no, you're not joining us for the first time, and you've been with us since the first Power Talk. I know some of you have been with us for some time because I see some familiar faces in the comments. So all right, the answers are coming in. Hi everyone. Oh, it's good to see so many new people. All right, some of you are joining us for the first time, some of you are not joining us for the first time. This is our fifth edition of Power Talk by Engineer 2021. For those of you who missed it, the question that I'm asking is if this is your first time joining us for Engineer Power Talk. Interact with me using the comment section. Type Y for yes and N for no. Wow, all right. I see all of you present here today and eager to start the Power Talk session. Thank you so much. And thank you so much for interacting with me. It's really refreshing to meet new people in this platform. Back to the Power Talk. This Power Talk is brought to you by Engineer 2021, which is Malaysia's first engineering exhibition and convention scheduled to take place this year from 1st to the 4th of December at Kuala Lumpur Convention Centre. Engineer 2021 is jointly organized by IEM and CIS, and we strive towards becoming the premier business event for engineering community. We have prepared a short video to show you how you can leverage on this dedicated business event for your business. Let's check it out.
Engineer 2021, an event of IEM Convention, will be the flagship event for the region's engineering professionals and community. It is IEM's hope that this hybrid exhibition platform will complement our role to uplift the industry and to prepare our profession and talents for the future of engineering. Engineer 2021 aims to build on friendships, leverage on partnerships, and forge collaboration for the fraternity as we come together towards recovery from the after effect of the global pandemic. At IEM, we highly welcome our local and international associates and industry friends together and discover the latest technologies, innovation, and solutions beyond borders. Together, let us contribute towards the growth and success of Engineer 2021, the engineering gateway to ASEAN.
Yes, we are as excited as you are with Engineer 2021. Be sure to stay on until the end to know how you can be a part of this excitement. All right, back to today's session. Ladies and gentlemen, when you stay to the end of this Power Talk, you will learn about both the present and future concerns with regards to both electrical safety and available irradiation technology that will hopefully drive improvements in the built environment. Do note that this session is CPD applicable for all BEM and IEM members. Follow the instructions in the comment section and be ready to claim your CPD point. We've also shown the instructions at the opening slides earlier, so watch out for the sign in and sign out codes. If you have any questions that you would like to direct to our panelists, feel free to type your question in the comments as well, and we will attend to them at the end of today's session. Our topic for today's Power Talk is electrical safety and irradiation technology for an improved built environment. And a special shout out to the Electrical and Electronics Association of Malaysia, or TEAM team, for making this talk happen. We are honored to have two special guests as today's panelists. Here are the speakers for today. Engineer Kok Yen Kwan, Vice President and Chair of Engineering Construction and Services Group for TEAM, and Mr. Gaurav Yadav, Senior Product Manager, Professional Channel from Signify Malaysia Sendirian Berhad. Today's session is moderated by Datuk Engineer Azlan Robert Abdullah, the Safety Committee Chairperson from TEAM. Let me share a quick background to introduce our moderator. Dato Azlan graduated from University of Brighton, UK, with Bachelor of Science in Honours for Electrical and Electronic Engineering. He has over 35 years of experience in the electricity supply industry in various capacities. His experience as a research engineer in TNB research has fueled his passion in the emerging technologies. This is evident in the many projects he has embarked on, including green technology projects. A man with many talents, Dato Azlan has attained a CPL helicopter license, which enables him to pilot corporate helicopters for transmission lines surveys and maintenance utilizing state of the art airborne technologies. Dato Azlan was also the general manager of Perusahaan Automobile Electric Malaysia at Uniten Bangi, where he was involved extensively in the overall management of the manufacturing activities and the business development of the company. He has held various posts in Tenaga Nasional Berhad, and this has given him vast knowledge and technical skills as well as leadership competency in the industry. Dr. Azlan's passion has driven him to establish RAZ Engineering in year 2000 and has contributed to the electricity industry from system design to project management and consultancy. He is a corporate member of Institute of Engineers Malaysia, a professional engineer certified by Board of Engineers Malaysia, a certified competent engineer 33 kilovolt, and also a certified services engineer by Suruhan Jaya Tenaga. Without further ado, ladies and gentlemen, let's bring in Dato Azlan on screen with me. Hi, Dato
Hi,
Azlan.
hi, Lillian. Good afternoon to you. Hope
Good
you're
afternoon to you
well.
too. I'm doing
Yeah,
well. I hope you're well too.
so thank you.
All right, I'll pass the
Thank
floor over
you.
to you.
Right. Thank you, Lillian, for your illustrious introduction. Good afternoon, everybody. Let me wish everybody present Assalamualaikum, Salam Sejahtera, and a very good afternoon and a warm welcome to everyone to the fifth series of Engineer Power Talk. I'm Azlan. I will be your moderator for today's session. Today's topic is electrical safety and irradiation technology for an improved built environment. Whilst we and the world continue to combat this ongoing COVID-19 pandemic, enforcing movement control orders and other hurried decisions on restrictions, serious consequences have begun to surface. In this Power Talk series, we will discuss current issues and challenges, and we will listen to the sharing of two different but similar issues on health. One, from the perspective of health of electrical installations, due to neglected issue on safety, electrical safety, as a critical component in the maintenance regime of the built environment, as a result of restrictions enforced haphazardly during the pandemic. The other is from the perspective of human health. Advancement in technology has also driven the adoption of ultraviolet irradiation as a means to improve air quality, especially in indoor environment, and has been scientifically proven to combat all known bacteria, viruses, and microorganisms that may pose danger to human health. This Power Talk series aims to address the present and future concerns with regards to electrical safety as a consequence arising from neglected critical maintenance, not able to be implemented due to the pandemic, and the availability of UV radiation technology that will drive improvements in the built environment. To discuss and share further on these topics, we are happy to have invited two specialists in their field, and they are Engineer Kok Yeng Kwan, Vice President and Chair of Engineering Construction and Services Group of the Electrical and Electronic Association of Malaysia team, and Mr. Gaurav Yadav, a Senior Product Manager, Professional Channel, Signify Malaysia Sendirian Berhad. Before we get on with the business of the day, a small announcement. Please feel free to drop your questions in the comment section, who it is directed to, and we will do our best to answer them before the end of this talk. Now, with that, let me introduce the first panelist for today's session. IR Kok Yeng Kwan is a practicing professional engineer with more than 17 years of experience in the building construction industry, and is the principal energy engineer of an energy green building and commissioning firm. He is a board of engineers, Malaysia's registered professional engineer with practicing certificate, chartered engineer with the Engineering Council of UK, and also registered as both electrical energy manager and a competent electrical engineer up to 33 kV systems with the Energy Commission. He is currently focusing his work on sustainability, energy management, and also building inspection audit, where he is both a trainer and inspector accredited by Architect Center Sendirian Berhad, a subsidiary of the Pertubuhan Architect Malaysia, focusing on property inspection and building advisory services to the Malaysian public, and have inspected more than 50 installations of various types and on electrical safety and compliance issues over the past 5 years. Professionally, Engineer Yeng Kwan is currently the Vice President of the Electrical and Electronic Association of Malaysia team and chair its Engineering Construction and Services Specialized Group, and have previously chaired the Green Technology Committee. He represented the association as an esteemed judge at both the iProperty Development Excellence Award, IDEAS 2017, and the MBAM's inaugural Construction Industry Trade Awards, CIA 2019. He was also recently a committee member, a representative of team on the drafting of the Building Energy Efficient Regulations, BSEER, as part of the overall drafting of the Energy Efficiency Conservation Act. Without further ado, let me invite Engineer Kok Yeng Kwan to join me on screen.
Hi,
Hi,
Dato'.
welcome. Hi,
Dato'.
welcome.
How are you,
Yeng Kwan.
Dato'?
Fine, thank you. Fine. How are you today?
I'm good as well. It's good.
Okay.
It's always good to meet again here online. Yeah, we can't do
Yeah.
it physically, obviously.
Okay. Now, I
Yeah.
think everybody is excited and to
Yeah.
hear your sharing. So the floor
Alright.
is yours, Engineer Kok Yeng Kwan.
All right, Dato'. Thank you, Dato'. Okay, good afternoon, everyone. Hope everyone, like Dato' say, is healthy and safe as well during this pandemic session. Of course, the issue on safety and health, I think it is paramount and it involves everybody, right? It doesn't different between age, race, or whatever background you're coming from. So we're going to tackle both of these issues, and obviously team coming from these two electrical and electronic background, E and E, right? We will focus on the electrical side of things. I will be speaking on safety, right? And on the health side, I think Gaurav will talk about it more later on, right? So since it's an afternoon session and it's after the lunch, right? Let's begin with something that is more lighthearted, right? I'll show you a screen. This screen here, it looks more from a Hollywood movie, right? I think let's take half a minute, right? Just for sharing. If any one of you know this message and where it's coming from, code red for humanity, maybe you can reply in the comment box and I'll see any one of you are aware of this. I think apart from the global pandemic, this particular issue is actually very hot at the moment. So let's see if any one of you have read the news or you are aware of this code red for humanity. If any one of you know about it, please reply in the comment box. Let's see if how many of you are aware of this. We'll take a 20 to 30 seconds. I'll wait for your reply. If any one of you, of course, we don't have prizes. I think the prizes, the lucky draw or whatever, you have to ask the host, the CIS network. But anyway, let's see if any one of you knows about code red for humanity that happened recently. Is there anyone that is replying? Anyone that are aware of this? I haven't seen any reply, so I will assume that yeah, good. I think Siron, Muhammad Siron, yeah, very, very good. Yeah. At least I'm getting one straight away, I'm getting one positive reply already. Okay, anyway, without further ado, code red for humanity, if you all follow the news, is actually on climate change, like I think Muhammad Siron have replied. Recently, the IPCC, which is an international expert panel on climate change, have issued their latest report, and code red for humanity was actually their title. If you Google IPCC, you'll find tons of information on this, and it's actually a really, really big warning to human, to all of us, to our current generation, to our future generation about climate change. And if any one of us still doesn't believe in it, what will happen to us in the very, very near future, right? This is just more for info and more relaxing start to the talk. So now getting back to our business of electrical safety. I think electrical, without saying too much, is the lifeblood of buildings. That's what I call it. Because if you look at buildings, right, every facade of the buildings, right, depends on electrical system. It's like our body, our human body is like the heart and lung, running the building. So it really is dependent on electrical system to sort of power up buildings and installations, right? So it's really, really important. So then the key issue is I want to remind all of us, since this is an engineer show, right? All of us fellow engineers and fellow professionals, right? Of what our duty and professional liabilities are. I think this is very, very important, right? Because later on, I'm going to show a lot of examples of current practices, which obviously doesn't really gel into professionalism and code of conduct. So if you look at duty of care, this is the Bolam test. It's actually a law term, it's a legal term. But what it does is that it says that that is enough, is sufficient for you to just practice your ordinary skill as an expected of an ordinary engineer, right, in your particular act. So if you are electrical engineer, you're supposed to know basic, at least what is safety, what is electrical engineering, that kind of work. So what do the board of engineers say? For some of you, this is actually common paper for the PCE exam. Which is the PEPC, right? That one that you can get your IR for PEPC, right? A reasonable understanding of professional liability pertaining to duty of care and due diligence to the client, right? So this duty of care and due diligence, which is very important. And again, in the CP, the common paper, the minimum that you should know about professionalism, whether professional or duty of care, standard level expertise, right? I think I don't need to read all of this. It's just a reminder, right, of our responsibility and our role as engineer, as professionals, okay? So since I think this is an IEM show as well, what do IEM say? This is just a reminder. If any one of you, I would expect that all the IEM members would know this, but this is just a reminder of what IEM's professional conduct says, right? Professional advice. A member called upon to give an opinion shall be the best to his ability, give an opinion that's objective and unreliable. Objective is the key, right? Objective and reliable professional advice, okay? Reasonable care. A member shall also at all times take care to ensure that his work and product of his work constitute no avoidable danger of death to any person, right? And then the third one is engineer's responsibility, right? I think all of this, like I say, I don't need to go read it word by word because I think it's available online. It's available on IEM's website. You can go through it. But this is just a reminder, simply because, like I said, the issue that we're going to discuss later actually comes back to all this, right? So, a lot of people question: Do Malaysia have enough law? Do we have enough guideline? Do we have sufficient information for professionals to lead into? If you look at just guideline like this, right, standards like this by the Malaysian standard, by IEC standard, by Suruhanjaya Tenaga guideline, I mean, from my own personal opinion or from my own experience, I think Malaysia has sufficient guidelines and laws, to govern us. It is up to us as professionals to practice it, to practice a guideline, right? I think we definitely have it. I think this is just the one that I'm showing here is just actually a part of it. Suruhanjaya Tenaga alone have like tons of information for us to lean into, right? So, just a reminder to all of us. I think this one, even a lot of electrical engineers have forgotten about this. So the question is, right, how much or how many amps of electricity can we get before we get killed? Do anyone know? So this is going through. This is a table, right? It really depends on actually your age. Actually, it's very dependent on individuals. Your age, your size, whether you're male or female, and then your health and everything. But generally, what happened is that Malaysian, as a human being, expert have actually tested on human. Averagely, we can take about 30 to 50 milliamp of electricity only before we get ourselves killed. Generally, before our muscle contracts and we get ourselves killed, right? So this is how dangerous it is, because even your kettle or even your home appliances, right, is much many times higher than the 50 milliamp, right? That is why electricity is very, very dangerous. I think this is it's a reminder, right? So actually, electrical work is about risk. It's always about risk management, risk assessment, right? And again, like I say, this go into the example that I'm going to talk about later. But this is just a basic description about what is risk, what is risk assessment, right? And do we as engineer, right, do this all the time before we get into the work? So how do you do risk assessment, right? The question is how, right? See, in simplest form, this is an ABC standard, I call it, right, of doing electrical risk assessment. And I think this ABC is so simple that actually is practicable over a whole sector or all stakeholder, be it you are the consultant, you are supplier, you are selling product, anything to do with electrical. I think you can use this ABC as a simple guideline. Do you evaluate your risk hard enough, right? Do you protect human? Do you protect public? Do you protect people's interest? Do you protect property? These are the things that the code of conduct mentioned just now, right? So now we go into the real thing, right? The real deal. Okay, if you look at this, right? These are pictures, right? The picture on the left, the switchboard is flush to the wall, and they creatively open a hole at the bottom, right? Just for access. But if there's anything that's going to happen, it's definitely not going to be very pleasant. And also, in fact, this switchboard is also housed inside a pump room, a main pump room without any protection as well, and even without any rubber mat, you can see. And to prevent water from entering it, they actually put it on a plinth. So is this correct, or is this safe enough? So no, are we going to be answerable? So the picture on the right, I think this is very typical. I think a lot of you have experienced, especially in shopping malls, in hospital, everywhere. So the engineers or the designer will always give this reason. They will say that the architect did not allow us to remove the parking space. But again, like I said, the professional conduct just now mentioned, right? You as a professional, you should be the one highlighting to the architect to say, no, look, by electricity regulation or act, there shouldn't be anything that's obstructing entrances to main switch room, substation, right? And this car is happily parked in front of that. You can imagine if there's anything happen, how are you going to assess the room first thing? Or if there's an explosion or there's an electrical incident happening, how are you going to assess or protect even the car or whatever? Anything can happen. So again, this go back to, like I said, the what I have mentioned just now. Are we doing enough to discharge our responsibility, right? Something to think about, perhaps. So then you ask the question, or do you have safety and working clearance? How? I don't know. People say I don't know. This is actually a guide. This is actually a table that's taken out of Suruhanjaya Tenaga's guideline on non-domestic installation. It's free. You can download it from Suruhanjaya Tenaga, right? And on the right is one of the best ever installation that I have ever seen, right? So if you were to tell me that Malaysian cannot do good work, that is wrong, right? This is in Malaysia, this is in Klang Valley, this is in KL, right? It's well lit. The room is well lit. All the switchboard is well placed, and then there's enough clearances to work, right? Everything is done properly and is properly labeled. Everything, each of the panel is properly labeled. Each of the outgoing circuit is properly labeled. So it's not right to say that Malaysia cannot do proper work, right? Our contractor cannot do proper work, right? So going back to the not so nice views, right? Again, this is very typical in Malaysia. You can find it, right? You have this it's not a nice word to you, but it's actually sanitary, which is actually technically sheet pipe together with your main switchboard inside a room, inside a main room. If you look at the picture on the right, that S-build drawing is in this state is simply because the pipe has burst many, many times, right? So again, as engineers, as professional, as designer, right, or even as the installer, as a contractor, is this right? Are you discharging your duty correctly? Are you supervising your work correctly? And the contractor, have you coordinated properly? So these are all the questions that we should ask ourselves, right, as engineers, right? Correlating back to the code of conduct just now that I mentioned about professionalism, right? This is very, very typical, in fact, right? There's actually no coordination aside, water pipe, sheet pipe, whatever pipe is all installed in the same room, right? And nobody care about it. When things happen, right, the blame game start, right? So again, this one is another one. This one is a condo. Because of the way that they have laid the floor, the main contractor, the leveling is not correct. So the water actually backflow into the electrical riser, and the tap off unit and everything exploded lah. So you can see the damage lah, right? From this. Again, like I said, this is actually all about coordination only. It's not even rocket science, right? And again, this is actually very typical, and it's happening everywhere around Malaysia, right? Klang Valley especially is bathtub tap off, everything exploding because of water leaking is right, very, very common now. And again, the question is, are we going to be responsible? Are we doing enough for the industry? This is a very, very classic case. One of the worst, I would say. If you look at the trenches in this particular substation, right, or I should say in this particular installation, there are about 3 to 4 substations. All the rooms are full of trenches like that, very, very deep trenches. So what happened was that the designer and the contractor have dig all these things, supposedly from the original contract, for TMB cabling. And after the project got run, they changed the routing. So conveniently, everybody just leave this behind. But the sad thing is that to cover up what they were doing, right? Then I think people complain that people might fall down. There can be incident. So you can see here what they did with it. They used a lamination board to place on top of the trench and then cover it with a rubber mat, right? You just imagine if you are not aware and you step onto the lamination board and your leg goes straight down the trench, and what will happen to you, right? This is really sad. Like I said, the way that it's been done, right? If you have said you dig the wrong trench, it's okay. In fact, you don't even need to cover it back out. You just need to put a cover, trench cover to cover it up. It's not going to cost you millions. But again, like I said, this is not about money. This is about our discharge of responsibility as professionals, and also as a code of conduct, everything like I mentioned before. But of the most interesting thing that I want to show you is that, of course, this doesn't really go well with a lot of consultants out there, right? The saddest thing about this particular case is that this is actually the reply from the professional, right? They are saying that to cover it up is not in the contract. right? And also, this room is actually accessible by professionals, by competent person only. The trench is definitely not in order, right? And it's about safety, like we have mentioned about the code of conduct of professionalism. Duty of care of the person is to protect the public, right? Just now we read about that, right? So it's really sad when our role is just actually to protect ourselves, in fact, right? It's not actually for public interest anymore, right? It's just like you going to a doctor and imagine if a doctor have incidentally cut you at the wrong place, let's say an operation, and then he said he have to leave the wound open simply because you didn't budget for the reclosing of the wound. How sad can that be, right? As professional, right? And the best part of it is that actually, of course, I cannot show it, right? But the electrical engineer don't even dare to sign off on this letter. He got the mechanical partner to sign on this letter. So the mechanical engineer is actually writing an electrical safety letter. How wonderful can our industry get, right? So this is really, really bad, right? This again, so another, this is not so typical. This is a 33 kV system. And what happened is that they have is almost like a bullet that has gone through the cable. This is at the cable joint, the 33 kV panel, right? So what happened was that the jointing was actually done by non-qualified person. So I would suspect it could have been done by foreign workers lah, right? So when questioned by the owners, right, how come in other parts of the building the installation was okay, the joint was okay, and this one is okay, or they say it's done by different group. So again, like I said, this is about saving monies. Basically, it's all about cost and cost and cost. But the code of conduct and professional practice, right, calls for a duty of care and professionalism, which I think we are very much lacking lah. And on the right, the last picture is that when the chargeman or the owners group ask for the rubber mat, insulation rubber mat, which is a requirement under the law. So that's what mat they give, a carpet mat, right? So this is the work by contractors, right? So they actually give a carpet mat to replace the insulation rubber mat, right? So I think there's enough of some actually, because the time is actually very limited. So it's enough example. So I will bring you to statistic, right? This is by Bomber Malaysia. So if you were to look at the Bomber headlines, right? Of course, this is a few years back, but I think the statistic is still the same. Of course, we don't have the data from Bomber at the moment. Faulty power source is the number one cause of fire, right? And if you look at this, electrical source is almost champion now. They lead by like ways ahead of most of the other major causes lah, right? So I think to show you the picture just now is just to remind all of us, right, that actually we should really do something about it, right? And not just let it continue doing like that. So the question now would be, right, what can we do, or what can you do? What should we do? I call it the RAT concept lah, the RAT concept, because to make it easier for everybody to remember. The RAT concept is like this. It's actually the first one is the R, which is to rethink. I think all of us, all the stakeholders should really rethink of what we are doing. And by this, I don't mean that us, let's say as an engineer or whatever, it's actually the entire value chain. From the consultant to the contractor to the engineer to the testing engineer to the site engineer to the supplier and even the traders, right? Whatever we do, we should really rethink of how we can actually protect and do better, right? And after we rethink, actually we should do the assessment, right? Something like maybe even the risk assessment that I mentioned about, and all the things. Let's say, for example, even if you are supplying something, and if you're supplying something that doesn't even have basic conformance, safety conformance, you're actually risking people's life. Now a lot of people complain about online sales of electrical items. Are they safe? Do they comply to minimum standards? That kind of thing. This assessment. We should really assess. That's why I say it is not one party kind of thing, but it should be by everyone. We should really assess. And the third one is, I think, that I really want to champion is actually transcend. We should actually really go beyond of what we are doing, because at the moment the industry is the thing that I realize is that everybody is trying to protect themselves and protect their own interests. I think that shouldn't really be the case, and we should really go beyond that. The basic, when you talk about safety, it's always going beyond the basic, right? To to actually improve the industry and actually improve safety for everybody concerned, right? So I think this red concept is something that perhaps everybody can keep in mind. And if we don't keep this red concept, I think the red concept or red consequence that we're going to get is something like this, right? Which is the red on the right, right? This is actually also very typical. I think those of you who are in the electrical and maintenance line, right, you can really relate yourself to this. This actually inside a main switchboard, obviously. So the red went inside because there were holes, right? So and then of course it died inside, and it is quite sad. This particular case, because we attended to it. When the electrical shock that killed the rat, right? You just imagine how powerful it is. When we pick up the rat, right, the head just fell off. When you look at this picture, the whole body is still intact, but when we pick it up, the whole head, the rat head fell off, right? So you can imagine the impact that he had and how he got killed, right? So moving forward, I call this the DIOM cycle. I think anyone who are in the building and construction industry, I think you will probably know this: design, installation, operation, maintenance. But what I want to say is that the normal DIOM way is that we start from design and end at maintenance, right? But if you look at the real case or the practical thing that's happening in the industry now, actually, the D and I is one group, the O and M is another group. And the gap between the D and I and the O and M is getting bigger and bigger every day. And these two parties just simply do not talk to each other. That means the design and installation team will just do it their own way, and they couldn't care less about the operation and maintenance team. So the operation and maintenance team, when they take over projects, right, they get into a lot of trouble because whatever they are maintaining does not even meet minimum results. So I think moving forward is actually about reversing the DIOM cycle of what I call it. What do you mean by reversing the DIOM cycle? Is basically to say that, look, from the project onset, perhaps every party can probably consider some of the view of the O and M team before they even start designing installation. I think and this will definitely help the industry to improve overall, right? So it's about reversing the DIOM cycle of what I mean by it, right? And of course, this is my last slide. I want to borrow this quote by somebody. I find it very inspiration. I saw it in the internet recently. Is this? This guy is called Louis Purge, right? He's actually an UN ambassador, United Nations ambassador, and he's also an endurance swimmer. Recently, he swam across the Arctic, in freezing ice cold temperature, and he has this to say: every generation has the opportunity to change the world, to make it better, safer, and more just. We must be that generation, and I think it's very, very true of us that we really, 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 really should actually be the generation to change this and stop this rot about the industry getting worse and worse and worse and worse. So hopefully with that, I have shared some very basic insight into electrical safety to every one of you. All right. And I look forward to speaking with you during the forum later. I pass back to the floor to you, Dato' Aslan. Thank you.
Thank you, Engineer Kok, for your insightful sharing on this critical issue of electrical safety. I agree with you 100% on your presentation. Being a fellow engineer, doing the same thing as you do, seeing all the things that you have presented, and also having the same thoughts as you. I think it is high time, as you say, it is high time we need to rethink about this whole issue of maintenance, operation, design, and everything, you see. So I think it is fantastic that you have brought up these issues again, and I hope that we can share even this with the authorities and even the regulators,
Right.
And the only way to do this is to continuously, I think we need to continuously engage with them, because we need to continuously engage with them. Anyway, thank you again, Engineer Kok, for your sharing. Right?
Thank you, Dato'.
So, moving on, ladies and gentlemen, our next panelist is Mr. Gaurav Yadav. Let me introduce him. Mr. Gaurav is a graduate in mechanical engineering and industrial management from the Indian Institute of Technology, Banaras Hindu University in 2010, and also holds an MBA degree from Nottingham University, Kellogg School of Management in the field of marketing and strategy in 2018. He is the product manager in Signify Malaysia Sendirian Berhad, formerly known as Philips Lighting. He has more than 10 years of experience in leading end-to-end strategy and cross-functional marketing execution for complex, high-growth product portfolios, focusing on speed to market, product quality, and profitability. Skilled in the product management, product marketing, innovation marketing, and market research associated with consumer durables and lighting. Mr. Gaurav has joined Philips in India in 2014 and currently based in Kuala Lumpur, taking care of the indoor luminaire markets for Malaysia. He is also responsible for the new product launches, such as UVC disinfection range, indoor, industrial, retail product ranges, product lifecycle management, customer insight generation and value proposition testing, demand forecasting, and supply planning. In a nutshell, Mr. Gaurav is a management and marketing guru. With that, let me welcome Mr. Gaurav onto screen with me. Hi, Mr. Gaurav.
Hi, Dado Aslan.
How are you today?
Hi, how are you?
I'm fine, thank you.
I'm doing good. How are you?
Good. You look great. You look great. Yes. Okay, Mr. Gaurav. Without taking more time off, let me give the floor to you for your presentation.
Okay, thank you, Dado Aslan. Okay, so today I'm going to talk about that, how you can improve the indoor air quality by using the UVC irradiation technology, because I think this is very important in today's scenario, because today's we are facing this pandemic. Even not only we, even the whole world is facing this pandemic because of SARS-CoV-2 that is primarily responsible for COVID-19 disease. So so that is why it is very important to take good care of our indoor air quality. So I'm going to talk about how this technology works and what are the kind of solutions we are having at present, and which is also recommended by WHO, Center of Disease Control, by KKM Malaysia, by National Environment Agency Singapore, because all those bodies has also acknowledged the same, that what is the kind of a solution we can be implement to improve the indoor air quality. So what you should know about UVC. So UVC light has three different components. Let me open my pointer as well. So UVC light has three different components: UVA, UVB, and UVC. And you cannot see UVC from naked eyes because the UVC light spectrum is an invisible light spectrum. So you cannot see UVC light from naked eyes. UVA is the kind of a mildest component. Wavelength of this UVA varies from 350 nanometer to 400 nanometer, and it is primarily used for curing, sun tanning, or insect traps. So you have seen those blue color of lighting lamps, which we are going to use to trap the insects. So that is basically UVA. UVB is little bit higher in terms of intensity, and that is primarily used for medical purpose or to treat some of the skin conditions. And UVC is the light which can be used for disinfection purpose or germicidal application. So what does it mean? To disinfect all those bacteria and viruses, so that is why UVC is being used for disinfection and germicidal applications. And how this technology works? So when you put UVC radiation onto the virus, bacteria, spores, or mold, then it will break the DNA and RNA of that bacteria and virus. So what does it mean? They are not able to multiply their number. So in a way, they become inactive. And that is how this technology works. So till date, there is no known microorganism that is resistant towards this UVC. So it's a very effective technology. And if you just put this UVC rays onto the bacteria and virus, they will become inactive. And this is the safe and effective technology which is being used from more than 40 years in various hospitals and various government buildings. And the peak output of the lamps is 253.7 nanometer. So, like if the peak output of UVC lamp is 253.7 nanometer, then it is the kind of a most effective wavelength. So how the virus can be spread into the indoor environment? We really need to understand what are the different channel of transmission of a virus or bacteria. Because once we understand this, then only we can think of what are the kind of a solution which can be implemented to avoid the transmission of those virus and bacteria into the indoor environments. So there are three different modes of transmission. The first mode is direct airborne transmission, and that will happen between the people. So what does it mean? If a person is infected, if he sneezes out and coughs out, then the virus can sustain in air for certain amount of a time. If I talk about this SARS-CoV-2, it can sustain in air for 3 to 5 hours. Or the new mutants of this SARS-CoV-2, they can also travel a farther distances. They can travel a longer distances into the air. Then direct airborne transmission happens when the one person is talking to the other person. So it means the time of transmission is very, very less. So within seconds or within minutes, the other person can be infected. So that is what direct airborne transmission. Coming to the indirect airborne transmission. So what does it mean? If a person is infected, if he sneezes out and coughs out, then the virus can sustain within the air for certain amount of a time. And it can also reach from one area to other area through the building ventilation system. And it can infect other people into those areas. So that is indirect airborne transmission. If I talk about indirect surface-borne transmission, so what does it mean? If a person is infected, if he sneezes out and coughs out, then virus can sustain on various surfaces for a certain amount of time. And if the other person touches that surface, then the other person will be infected. That is indirect indirect surface-borne transmission. And all our solutions, so whatever solutions we have seen in the market, they are just targeting how to avoid this indirect surface-borne or indirect airborne transmission. Because direct airborne transmission you cannot avoid, because time of transmission is very, very less. So I think certainly the vaccine is the best possible way to avoid this direct airborne. So we get we generate the immunity, like no other bacteria and virus can harm us. But you can certainly avoid this indirect surface-borne or indirect airborne transmission via various solutions. How does airborne transmission happen into the indoor environment? So this is how the indirect airborne transmission happen into the indoor environment. So when the person is infected, it depends on the size of the droplet nuclei. So if the size is large, then those virus can travel up to a distance of 1 meter. If the size is small, they can travel from 1 to 2 meter kind of a distance. And we should be much more worried about those infectious droplet nuclei, because the size of these infectious droplet nuclei can be less than 0.3 micron, or they can travel up to 60 meter of a distance. And when the infected person spread this virus into the indoor environment through the building ventilation system, these bacteria and virus, they can move from one area to other area and infect other people. And that is how the virus transmission happen into the indoor environment. How we can avoid that? So we need to look at what are the solutions available in the market, and maybe like what are the today's scenario, what kind of solution we can put into place so that we can avoid this airborne transmission. I just want to highlight what some of the bodies has recommended, the government bodies has been recommended, and based on the different studies they have given this recommendation. If I talk about KKM Malaysia, what they are saying, that to avoid this, to improve the ventilation in the healthcare setting, what you can use UVGI. UVGI stands for ultraviolet germicidal irradiation solution. So you can implement UVGI kind of a solution for upper room, or maybe like within the ducts or within the AHUs, you can use this type of system so that you can avoid the airborne transmission. Or you can also use portable UVC for terminal room disinfection. For the room disinfection, you can use portable UVC type of solutions. What National Environment Agency of Singapore is saying, they are also talking about the same thing. They are also talking about how you can improve how you can clean the indoor air by using UVGI kind of a system. be it upper room UVGI or be it induct solution which can be installed inside the AHUs. So what is the need of UVGI system to be installed inside the AHU? First, I'll talk about ultraviolet germicidal irradiation system, which can be installed inside the HVAC system. So HVAC stands for heating, ventilation, air conditioning and refrigeration system. So, like in HVAC, how you can install UVGI system. So first thing is that the need to install UVGI is that we want to avoid sick building syndrome. We want to avoid conventional cleaning method. Because there are some disadvantage with the conventional cleaning method, and we want to avoid higher operational cost. So these are the three reasons why we need to install UVGI system inside the HVAC. So I'll just explain how a typical AHU looks like. So this is how the typical AHU looks like. The outside air which is coming inside the AHU contains all sort of mold, bacteria, viruses and other volatile compounds. Then there are dampers which will regulate the speed of incoming air. Then there are filters, be it HEPA filter or MERV13, all those filters are in place. What those filters will do, they will remove all those dust particles from the incoming air, and they will also remove certain bacteria and viruses. But those filters, till date, only they are able to clean 40% of those bacteria and viruses. Still the air which is coming into the indoor environment, coming inside the AHU, having 60% of those bacteria and viruses. Then comes this cooling coil. Cooling coil will regulate the temperature of incoming air, and through the blower, the air goes into the indoor environment. So this is how the typical AHU looks like. And then there is a return duct by which air again recirculate inside the AHU. So what will happen? All those bacteria and virus which is coming with the air, they gets accumulated on this cooling coil. And cooling coil proves to be a very kind of a breeding ground for all those bacteria and viruses because of the moist environment and because of the dark environment. That is the kind of a best environment for their growth. So they accumulate on the cooling coil, and that is why you can see in most of the AHU after some time there is an accumulation of that biofilm onto the cooling coil. So the HVAC system function is that to provide clean air into the indoor environment, and if biofilm gets accumulated onto the cooling coil, whatever air is coming inside, that will be with all those bacteria and viruses. So that is why it will enhance the sick building syndrome, because whoever people inside that building, they will infected because of those bacteria and viruses, and this cooling coil kind of add to further contaminate the indoor air quality. Then what are the current methods we can use to clean the cooling coil? So current methods, we are using those chemical cleaning or those mechanical cleaning methods, but many of the time they will damage the surface of the cooling coil, hence the life class of the cooling coil will be reduced. And those chemical can further come to the indoor environment with the air, and that will further contaminate the indoor air quality. And they can also be responsible for groundwater pollution because those chemical can seep into the groundwater. And this chemical cleaning and mechanical cleaning method you can do only periodically. It is not like day in, day out you can clean the cooling coil. You can perform that cleaning within 15 days or within 1 month of a time. So within that period of a time, the air will be, the infected air keep coming into the indoor environment. Third is the higher operational cost. When the biofilm gets added onto the cooling coil, your HVAC system needs to work harder. Your fan need to work harder to maintain the same temperature into the indoor environment. So that is why the efficiency of overall system is also a challenge, and you want to reduce the operational cost. That is why UVGI system should also be in the place. How does this UVGI system work? When you are putting UVC lamp in front of the cooling coil, so this is how typically the system looks like. This is how you can put lamps, so UVC lamps in front of the cooling coil. If you install UVC lamp, then when the air circulate within the AHU, that will be cleaned, and that will be clean from all those bacteria and viruses because of the UVC lamp, because of the UVC technology. This is how this system works. These are the various guidelines for UVGI's installation within the duct or within the AHUs. So ASHRAE is the American Society for Heating and Refrigeration. They talks about the kind of a irradiation level. If you are meeting those irradiation criteria, in a way you are meeting the ASHRAE guideline for the indoor air quality improvement. Then ISHRAE is the Indian body of ASHRAE. They have also mentioned that what should be the irradiation intensity within the AHU for the complete inactivation of SARS-CoV-2. So they are talking about SARS-CoV-2. So they are talking about much more stringent kind of a guidelines. Then the other guideline is UVGI rating. So those guidelines has been established by Kowalski in 2006. So certainly in 2006 there was no SARS-CoV-2, but there were other bacteria and viruses. So this is the third standard which generally we need to follow while designing a UVGI kind of a system for AHUs. What are the second solution? So, CDC has mentioned that to avoid the spread of SARS-CoV-2, what you can do, you need to use upper room ultraviolet germicidal irradiation type of a system. So this is how the system looks like. This is how you can install the devices within the room, and they will create a UVC zone on top of the room, and when the virus will circulate from downward direction to upward direction, because this is the kind of a natural movement of the air, and when the virus passes through this disinfection zone, then the virus will become inactive. So Center of Disease Control has also acknowledged the. So this is how the typical upper room system works. So this is a natural circulation of the air from downward direction to upward direction, and by putting upper room kind of a solution or upper air kind of a solution, you will create a UVC zone. When the infected air passes through that UVC zone, the air will become disinfected. So the question comes that why it is not being used in the past. So it is not the new technology, because we are in this current pandemic, we are talking about we are talking about kind of a different disinfection solutions, but it is not the new technology. In 1930 and 40s, it's still like people were using this upper room ultraviolet germicidation kind of a system. So you have seen those upper room kind of a system. It is being used very widely, and in 1970 and 80s, it is being used or recommended by WHO for the prevention of tuberculosis disease. How does this really work? So first thing is that we need to understand what are the different type of pollutants do exist into the indoor environment. So there are non-living particles, such as particles which are coming from automotive traffic. There are living particles such as those bacteria and viruses, and there are volatile compounds which is coming from paints and other building materials. So these are the three different components or pollutants exist into the indoor environment. So there are different kind of a solution. We can use different kind of purifiers to avoid all those non-living particles, or we can get the better order if you want to avoid those volatile compounds. But to eradicate or to inactivate those living particles such as bacteria and virus, because those particles are very small in the size. So the proper system into place, proper disinfection system needs to be in place. So what are the different ways of air disinfection? How you can avoid all those bacteria and viruses? First thing is that first method is dilution. So what does it mean? So you can pull fresh air from outside, or you can eradicate the infectious air from that indoor environment. So that is the one way out. You can improve the ventilation system within the indoor environment. That is called dilution. Then second come is filtration. So you can you can remove those bacteria and viruses through the filter, because you can use different type of air filters by which you can avoid those dust particles and other particles to improve the indoor air quality. Then the third method is purification. So you can use those UVC product or UVC energy, which can damage the DNA and RNA of those bacteria and virus, and that is how you are able to disinfect the indoor area. There are certain guidelines as well, because UVC, you need to use UVC in a safer manner, because UVC can be harmful for eyes and for the skin. So there are certain guidelines. While installing those upper room UVGI system, you need to make sure that those product follow UVC standard of ISO 15858, because that standard talks about what should be the minimum height at which you can install those systems, and what should be the irradiation level which is coming in downward direction. So this sets out a limit that the system need to be installed above the height of 1.7 meter. So at the height of 1.7 meter, the UVC irradiation should be in the safe limit. So that is the a limit for the safe exposure. So that is defined in this standard. So we really need to follow this standard while talking about upper room UVGI kind of a system. Now some of the guidelines, what should be the air changes per hour. So there are, because we need to continuously change the air from the indoor environment so that we keep circulating fresh air into the indoor environment. So the guideline is that you need to follow 6 ACH. ACH stands for air changes per hour. So that should be the method of, this is the typical value of ACH which you need to maintain within the indoor environment. And that will directly relate the kind of irradiation you are getting with those upper room kind of a system. So those upper room UVGI system, if they are generally delivering 5 to 7 microwatt per centimeter square, and that is equivalent to 18 to 24 air changes per hour. So now the question comes, why can't we just change air changes? We improve the air changes, and that is how we improve the indoor air quality. But there are certain risks with that, because if you change the air continuously from the indoor environment, that infectious air can go from one area to other area. So you need to find a way how you can disinfect that air. So that is why UVGI upper room kind of a system should be in place. So this is the last slide. What is the base? Last slide on the solution. Then I'll just take you through the live examples where how you can install. So let's say like this is how the upper room UVGI system looks like. You can install this onto the ceiling. You can also install this onto the wall. And this is the kind of a requirement. You know, like if you are getting this type of fluence rate, 2 microwatt per centimeter square, that is equivalent to 6 air changes per hour. And in this table, you can see that how much time it will take to eradicate SARS-CoV-2. If you want to eradicate SARS-CoV-2 by 99.9%, it will take 69 minutes. But generally, those upper room UVGI system are able to maintain 5 to 7 microwatt per centimeter square kind of a fluence rate. So what does it mean? Within 20 minutes of a time, you are able to eradicate SARS-CoV-2 up to 99.9%. Now, I just want to show you some of the application area and the actual installation. So this is how, you know, like you can do disinfection in the restaurants. Like people are eating around, but if you install proper upper room UVGI system in place, so you can install this type of luminaires in place, this type of products in place, so that like people can eat around, people can walk around freely, because the UVC zone will be created on top of the room. So it is absolutely safe when people are around. You just need to follow the safe guideline. This is how it can be installed inside the office. This is how it can be installed into the coffee shops, retail showrooms. So there can be so many examples, you know, like where you can just install all those upper room UVGI kind of a system, so that you are able to improve the indoor air quality. So I would just like to say one thing, because you know, in the current pandemic situation, we really need to think like how we can improve the indoor air quality, because that is very important. Not only about SARS-CoV-2, but there are a lot many other bacteria and virus which are present into the indoor environment. Because before SARS-CoV-2 also there are many pathogen and bacteria which can infect so many people and can also spread from one person to other person. So that is why proper indoor disinfection system should be in place to improve the indoor air quality. I think that's it from my side. I would like to pass on floor again to Dato Azlan.
Okay, thank you very much, Mr. Gaurav, for this fantastic sharing on such a wonderful and useful innovation that is so timely. It is always comforting to know that there are advanced technologies available to protect us, protect ourselves from adverse attacks from the current COVID-19 viruses. And thank you very much for enlightening us on this system of UVGI that you have available now. Thank you again, Mr. Gaurav. Right, to our audience again, please feel free to ask questions in the comment section, and remember to mention who the question is intended for. Now that we have heard from both panelists on two very relevant topics on the consequences of neglected electrical safety and the advancement of the UV irradiation technology, we would like to move on to the discussion forum and tackle some questions from the audience. And so without further ado, I would like to invite Engineer Kok to join us again on screen.
Hi, Dato. Hi, Garaf.
Hi,
Afternoon.
welcome back, Engineer Cobb. So you've been sitting quietly at the back there, listening, I hope.
Yeah. Learning from
Okay.
Garaf.
Yes. Okay. Let us begin this forum discussion. Right now, for a start, let me ask the first question, and this question goes to you, Yang Kuan. To you, Yang Kuan. Based on these many non-compliances work that have been what do you call this? You have raised so far, you know, in your presentation.
Yeah.
My question to you is, who shall be the liable party, and why is that so?
Okay. Thank you, Dato. Very relevant question. I think if you ask me personally, I think from experiences and all the installation, I don't think there's one party that would be particularly pinpointed or be responsible, because I would think that the way forward would be actually not to witch hunt. That means we don't go on a witch hunt to say it should be here, it should be you, it should be him, who's responsible. I think it should be a collective responsibility. I think what most of the non-compliance or so-called haphazard installation, it's not impossible task, you know, Dato. It's not an impossible task to take care. You know, it's just that everyone needs to play their part. It's simple. If you talk about a construction project, perhaps the consultant just need to be more careful with their design, and then they just need to be supervising more, perhaps, you know, the construction stages, right? And then the contractor need to just make sure that whoever they got on board to do the work are really competent, are skilled worker, right? Of course, they can have non-skilled worker for some minor works, right? But the important work needs to be done by skilled worker, right? And of course, the supplier need to play their part, obviously, by supplying good products, right? Yeah, not product that doesn't comply to even basic standard, safety standard, and that kind of thing. So I think it's a very overall stakeholder kind of thing. In fact, a few months ago, when I was also on a webinar with Radar member, in fact, and they were trying to push the blame to everybody else, of course, apart from themselves as developer, right? So I raised this to them as well, that you know, you shouldn't be that case. You know, but of course, if everybody want it to be done cheap, then that's what we're going to get, lah, right? Yeah. So I think that's my answer. Yeah.
Oh yeah, I being an engineer just like you, I can understand, you know, the issues. You know, our country, we have got our regulators, right, and we have got our Electricity Act, you know, and being and being a competent engineer, we are like the extended arm of the regulators. So when we go and do our visiting competent engineers job, and when we visit sites and we notice these issues that you have raised, you know, how do we address this? You see, during the design stages, everything is designed perfectly. I would say perfectly, okay? And during the construction, somebody is cleverer, somebody is more creative, okay? Right. So we have got a good condition that goes to a bad condition, and then it comes to these visiting engineers. Okay, of course, by the time the visiting engineer comes and visit, the damage is done. The installation is already installed. Now, how do we address this?
Okay, if you, I think again, it goes back to the issue. I think I addressed one of the thing. If you remember on my slide about the DIOM, right, is about reversing the cycle, because what you mentioned is rightly very true. That's why I was mentioning about the disconnection, right, between design and installation and the operation and maintenance, because a maintenance and operation person never ever get a chance to be involved from the project stage, right? So they will just take whatever that has to be there already, right? Like you say, right? That is the main problem, I think. So but again, I know of actually one or two developer or owners, they are actually now starting on that journey. As in, during their project stage, right? They actually start engaging with their future property management company, and then some maintenance stuff, right? They get them on board even for their normal project meetings, right? It's actually not to pinpoint. I say not to pinpoint or criticize the design or whatever, right? But it's just to say what is practical, what could help us in the future, that kind of thing. But at the moment, I'm not sure how many of these so-called owners will be willing to do that, because obviously there will be a bit of additional cost, right, to get these people on board at the early stage, right? So, but it's a good move, and I hope this will actually address the problem. So about your question on the visiting engineer, also there's a bad apples here and there. Not just, you cannot just blame it on the contractors or whoever, right? So we have installation where some of these developers, when you start going in and then you start commenting and whatever, they are very, very actually proactive, and they try to rectify the issues, right? But we also have seen our experience sites that the comment will be there for like past 10 years, and they couldn't even care less, right? That kind of thing, right? Until they wait for something to happen, like, in a way, right? So of course, a lot of people tell me, ST never say, why should I do? It's always pushing back to the authority, right? Suruhanjaya Tenaga, right? To say ST never say it's not safe. Why should I do this? That kind of thing. I would believe that for us to move forward, right, moving into the future, I think we should, as professionals, right, in the industry, everybody should hold hand and say, let's do it, not wait for ST to tell us to do it, right? I think that should be the right mindset, and I hope we can really do that, I think that, yeah.
Okay, thank you very much for your comment, Yang Kuan. Okay, moving on to Mr. Gaurav. There are many questions here, and there is a question here from Mr. Harry Adnan. Now, do Signify have other proposition on UVC to cater for other kinds of disinfection method?
Yeah, Mr. Harry. So basically, there can be three type of different disinfection method. So we just talked about air disinfection. So there can be surface disinfection, there can be object disinfection, like a UVC product can go for different kind of application area. So maybe we have the complete portfolio, and different kind of product we are having in our portfolio that can be used for different kind of applications.
Okay, another question to you, Mr. Gaurav, a very simple and very direct question. The question is the UVC light harmful to humans?
Yes. So I think that is a very relevant question, because UVC light can be harmful if directly exposed to human being or living being. So, that is why the solution which we have talked about today, that whether it is UVGI, which is going to be installed inside the AHU, or upper room UVGI, those solutions should be designed in such a way that, there is no UVC light directly exposed to the human being and living being. And there are solutions available in the market. So, or we can design, certainly we can design those type of solutions in such a way that there is no direct exposure possible. And if UVC light doesn't directly expose to the skin, then it is not harmful. It will only do the disinfection purpose, and that is why when you are using the surface disinfection product. So in that case, if you are using those surface disinfection, you need to evacuate the room for certain amount of time, let's say for 20 minutes or 25 minutes, for the disinfection purpose. But if you are going with this upper room UVGI kind of a system, or UVGI system within the AHU, that is absolutely safe.
Thank you for your enlightening explanation, Mr. Gaurav. I have one question for Engineer Kok here. Okay. To summarize, right, how do you see the industry improving over the future? What can we expect from all stakeholders moving forward?
Yeah, that is a very broad-based kind of question, Dato'. We need to gaze into the future, right, to see what we can do. But generally, I think it still go back to the red principle that I talk about, right? Rethink, assess, and also transient. We need to do better than what is the basic, right? Obviously, for example, if you have a guideline or you have an MS standard, IEC standard, right? That actually the people always mistake as the benchmark, but that actually should be the minimum basis, right? Where we should be, right? And we should be trying to think about ways to improve that. I think safety is the same. If let's say of a safety concern, like you mentioned just now, let's say all those visiting engineers outside, right? They should really raise and push it with the owners, right? To say, look, this is not right, right? And not just keep quiet or don't do anything about it. And of course, nowadays also we have a lot of technologies. I think some of even our own team members, the so-called big boys like Schneider Electric and people like that, they're actually coming out with a lot of new technology, even protection relay, that is our bread and butter, right? They are very, very advanced now, right? So it's how we actually also utilize and try to work with this technology, right? Industrial 4.0 and all these things, right? Because as far as like in the industrialized world, right? Like the advanced country, they are doing a lot of automated maintenance, they call it, right? Where they get a lot of these sensor, the IO 4.0, right? The Industrial 4.0, and where they can actually do offline monitoring, right? They will actually know their substation condition, things like that. Obviously that will take time in Malaysia's context, right? But I hope that this can be done. That means the stakeholder working together and also trying to utilize the technology, right? To improve things in the future.
Okay. I have another question for Mr. Gaurav here from the participants, right? Do you think for all future and sustainable buildings, will UVGI be part of the system that is to be incorporated in new building design?
I think that's a very relevant question, because not only because of this pandemic, we should think about the same. Because now we are dealing with this SARS-CoV-2, but there are lot many other bacteria and virus which came time to time and infect other people, and which can also be spread into those buildings. So I think going forward, we should really think of what is the kind of how we can improve the indoor air quality within those new buildings. So in my opinion, if I just say that all those buildings should come up with those relevant UVGI systems, because those are safe to use, people can work around, and at the same time, whatever occupants within that building get the fresh air. And I think that is the safest way by which you can improve the indoor air quality. And that is also effective, because no known pathogen and microorganism till date can sustain against UVC. So in a way, that is a very effective technology. We should also think beyond this SARS-CoV-2. Anyway, in today's scenario, we cannot say that after the vaccination SARS-CoV-2, we are just getting rid of this SARS-CoV-2, because this keeps mutating. New and new mutants are coming, and that is why it is spreading quite a lot around the world. But we should so COVID is going to be a stay. That is one factor. Another thing is that we should think about other ways. We should also think about other bacteria and viruses. So that is why those type of UVGI system should be in place.
Okay. Now, before we end our forum session, I have one last question for Mr. Gaurav, which is very direct, very simple. How much is the cost, and how many are already installed in Malaysia?
So in Malaysia, this upper room UVGI, we have installed, so at one of the eye healthcare setting, we have installed those upper air kind of a system in Optimax. Like every other office, they are using this upper room UVGI kind of a system. And at many places, they are also using UVGI system within the AHUs. So there are many malls, they are looking for this kind of a solution. Retail chains, they are also looking for this kind of a solution. And many new buildings also looking for this UVGI kind of a solution. So there are some example, now in Malaysia market also, at many places we have installed those type of solution, and we are getting many inquiries as well. And I think that is the right way as well, because now people are really thinking what are the ways by which they can improve the indoor air quality.
Okay, thank you very much, Mr. Gaurav. For those who have asked other questions, please do not fret, because we will try to get your answers, the answers to your questions directly or indirectly after the session, okay, from the various people. Now, so ladies and gentlemen, I think we have heard from two presenters who has presented and shared with us very interesting topics on health. As I mentioned, very similar but different, right? So we have addressed both the present and future concerns with regards to electrical safety as well as the available irradiation technologies. Therefore, we hope that it drives the improvement in the built environment, right? Before we end this webinar session, can we have our panelists to give us the number one key takeaway for our audience in line with today's topic? Let us start with Engineer Kok, please.
Okay, Dato. I think it's if you want me to summarize in 1 or 2 words, it's probably about self-regulation. I think I saw one of the comments just now on the chat box, right? That one of the listener was saying that code of practice, how many follow? I think this, probably the listener has been very frustrated, by the industry, that kind of thing. Yeah. How many follow, he was asking, right? The code of practice, right? So I think to summarize it, the key takeaway would be actually self-regulation, and I hope all of us can do it as professional, Yeah.
Yes.
Thank you.
Yes, thank you. And that's awesome a comment there, Engineer Kok. Now, what about you, Mr. Godaf?
Thank you, Mr. Dato Ajlan. So basically, if I want to summarize, the whole story shorter, so I would say that we need to follow the right solution, and we really need to think what are the right solution, how we can which can be improve the indoor air quality, because with this SARS-CoV-2 we need to understand what is the kind of a role that good indoor air quality plays into our life. So we really need to follow the right practice to improve the indoor air quality, so that in future those type of bacteria and viruses won't harm us, won't spread us like the world has experienced this SARS-CoV-2.
Yes, I agree with you. I think with us moving into an endemic, we have to live with the virus, and I think we have to seriously think of priorities and all those actions that we need to take to prevent us from getting sick. I think right. Yes, I think we agree with you. Yes. So with that, I would like to take this opportunity to say a big thank you to our panelists today, Engineer Kok Yen Kwan and Mr. Gaurav Yadav, for sharing your thoughts and knowledge in this Power Talk series. As a last note to our audience, congratulations on successfully staying until the end of today's Engineer Power Talk. And we at Engineer are excited to welcome all suppliers, manufacturers to be on board on this business event to rebuild our industry together. So if you would like to discover how to be part of this business event or in this Power Talk series, our team has posted a link in the comment box, and do click on the link to schedule an appointment with our marketing team for future discussion. Please join us at the upcoming Marvex Power Talk session happening on the 22nd September at 3 p.m. The registration link is posted in the comment section. And finally, do stay tuned for our next Power Talk session. Stay safe. Take care. Bye-bye, everybody.
Bye, everybody. Bye. Take care. Stay safe.
Yep.
Bye. Take care.
Bye.
Stay safe.
Take care.
Bye.
Stay safe. Bye.